Assalamualaikum and good day to everyone. Madam Jaswin here. So today's lecture is about chapter 6, which is flow measurement and measurement of liquid level. Let's start with introduction. So what is flow measurement? Okay, so flow measurement is a technique used in any process requiring the transport of a material from one point to another point. Okay, required basic knowledge. Okay, you must know and apply the knowledge of the direction and velocity of flow, like Reynolds number and also Bernoulli Equation. Okay, types of flow are laminar flow and turbulent flow. I'm sure that you all have learned before this in fluid mechanics subject, right? Okay, so let's recall. If Reynolds number is less than 2000, it is classified as laminar flow. So laminar flow is look like this, right, in a straight line. But if the Reynolds number is more than 4000, the flow is classified as turbulent flow. Okay, so how turbulent flow looks like is like this, right? So if the Reynolds number is between 2000 and 4000, we call it critical zone between laminar and turbulence, right? So next is Reynolds number. The formula is Vd over gamma. So V is the velocity, D is the inside diameter, gamma is kinematic viscosity, and Reynolds number is Re. Okay, so let's recall Bernoulli equation. The Bernoulli equation can be considered to be a statement of the conservation of energy principle appropriate for flowing fluids. The qualitative behavior that is usually labeled with the term Bernoulli effect is the lowering of fluid pressure in regions where the flow velocity is increased. Okay, we just recall this because you have learned before this. Okay, so the equation is energy per unit volume before P1 half rho V1 square plus rho GH 1 equals to energy per unit volume after, right? So P2 plus half rho V2 square plus rho GH. So as you know, P is the pressure energy and half rho V square is the kinetic energy per unit volume. And rho GH is potential energy per unit volume. Okay. So the often cited example of the Bernoulli equation is the reduction in pressure which occurs when the fluid speed is increased. Okay. So yang gambar ni you selalu tengok untuk menunjukkan macam mana Bernoulli equation effect. Okay. So flow velocity V1. Okay, bila dia lalu ruang yang sempit, the velocity will be increased. So that's why V2 is larger than V1. Sebab lagi sempit kan. Bila you kecilkan ruang, arus tu akan menjadi lagi laju. Where L2 is smaller than A1. Okay, tengok ni. The area, surface area is smaller than A1. And P2 is smaller than P1. Right? Okay, next we move to application. Okay, application of flow measurement. It is essential in many applications such as transportation of slurries, material or cement. Okay, contoh cement lah, you nak transport cement, ada piping cement dalam kilang kan, ataupun dekat construction site tu, you kena decide masuk secara laminar ke turbulent flow ke. Okay, and then compressed natural gas in pipelines, water and gas supply system to domestic customer and etc. Next element that's need to consider during flow measurement. What's the elements? First, clean or dirty. Next is wet or dry. Hazardous or corrosive or safe. Laminar or turbulent. Its pressure, okay, temperature and flow rate. Okay, so these criteria you all need to consider during the flow measurement, right? So next we move to flow measuring device category. So we have two categories, which first one is the primary devices quantity meter, and the next one is secondary devices, which is use rate meter. Okay. So let's go to primary or quantity meters first. Okay, so first, measure the amount of fluid in terms of mass or volume that flows past a given point in a definite period or time. So the technique applied is the time required to collect a particular amount of fluid is determined accurately, and the average flow rate can be evaluated. Okay. Advantages of these primary meters, okay, is simple, economic, and extremely accurate. Okay, so what method that have been used for these primary devices are volumetric method and gravimetric method. So what are the differences between volumetric method and gravimetric method? Let's see the differences. Okay, so for the volumetric method, the fluid flowing in the flow meter which being calibrated is diverted into a tank known as volume. Okay, maksudnya ada tank, volume kan, volumetric method. Okay, so ada tank known as volume. But for gravimetric method, the fluid flowing in the flow meter which being calibrated is diverted into a vessel. Okay, so dia akan diverted kepada vessel which can be weighted after a predetermined time. Okay. And also for volumetric method, when tank is completely filled, this known volume is compared with the integrated volumetric quantity, okay, which is registered by flow meter under test. Okay. But for gravimetric method, the weight of the liquid collected is compared with the gravimetric quantity, okay, which is registered by the flow meter under test. Right, so you should know the differences between volumetric and gravimetric. Right? Next, let's watch a video about the comparison between these two methods. now let's move to next topic, which is positive displacement meters, or sometimes you might heard the name is positive displacement pump. Okay, so what is positive displacement meters or pump? Okay, it is applied to a flow measuring device, so designed that the metered fluid is repeatedly filled and emptied from a space of known volume. Okay, so what is the principle? The liquid flows through a meters and move the measuring elements that seal the measuring chamber into a series of measuring compartments, each holding a definite volume. Okay, so what are the applications? Positive displacement meters are widely used in low flow rate metering application, where high accuracy and repeatability under steady flow rate condition are required. Okay, so the advantages are easy to install and maintain and have a moderate cost. Okay, so what are the examples? Okay, first is rotating disk meter. Example, application domestic water system. Okay, the second example is sliding vane type meter. Okay, to dispense petrol or diesel in the fuel filling station. Okay, so let's go to the rotating disk meter first. Okay, so these are the example of rotating disk meter. As you can see here, the brown color is the rotating disc. Okay, so this brown color is the rotating disc. Okay, this grey color is the rotating disc. The yellow color is the water. Okay, and this is the spindle connected to the counter, and this is the flow. Okay, so this rotating disc will go up and down, so it will rotate up and down. So when the rotating disc is going up, the flow will come in, and when the rotating goes down, the flow will go out. Okay, so let's read how it works. When fluid go through two inlet alternately above and below the disc, forcing it to rock in a circular path while rotating about its own axis. Okay, a small spindle attached to the sphere. Okay, a small spindle attached to the sphere traces a circular path and is used to drive the counter. And this notation represents a fixed quantity of water, so the total flow is calculated by the numbers of notation. Okay, so we discussed it before. Okay, these types of pump have high accuracy and repeatability under steady flow condition. Right? Okay, so let's see how it works. Okay, the video just now is for sliding vane type meter. Okay, the application is for dispensing petrol or diesel in the fuel filling station. Okay, so as you can see from the video just now, there are several vanes like this. Okay, so let's see how it works. When fluid go through to inlet, the rotor and vane around a cam, causing the vane to move radially. Okay, measuring chamber called as volume is formed between the two vane and the meter body. So from A to B is the measuring chamber. So you have a constant volume of the fluid. Okay, So a continuous series of chamber at the rate chamber per revolution are formed which deliver the flow to the outlet. Okay, so this constant volume is accurate lah for every dispensers. Okay, so accuracy plus minus 0.2% of the measured value and has low pressure drop. Right. So next example, commonly used device is the lobe impeller meter ataupun lobe impeller pump. Okay, so application is metering of gas and refined petroleum products. Okay, after this, I will show you a video about how the lobe impeller meter works. Okay, so as you can see here is the inlet and outlet, and this is the rotating lobe. Okay, up and down, measuring chamber volume is here. Okay, and this is a wiping contact. Okay, let's read together. Two rotating impellers designed with a figure 8 cross section, okay, like this, rotate in opposite direction due to the force exerted by the gas flowing being measured. Okay, the shape of the impellers, like this, the 8 cross section, prevents contact while the gap between them remain constant. A gear drive external to the measuring chamber synchronized to the impellers. During each rotation, 4 crescent-shaped volumes are moved through the measuring chamber, and the number of rotation is proportional to the flow. Okay, so let's see a video that show how this lobe impeller Next, we move to secondary or rate meters or rate pumps. Okay, so this type of measurement instrument, they not measure the flow directly, but instead measure another physical quantity which related to the flow. So these devices can be categorized into two types, which are flow rate meters or velocity meters. Okay, the principle of flow rate meters are first variable head meters, variable area meters, variable head and variable area meters, and fourth is constant head device. Okay, next, the principle of velocity meters, or we call it anemometers. Okay, first is variable head meters. The example is pipetted tube. Okay, I'm sure that you have heard about this pipetted tube before this. Okay, and then target flow meter, turbine propeller type meter, ultrasonic flow meter, hot wire or hot film anemometer, and laser Doppler anemometer. Okay, so next let's see how pipetted tube works. Okay, so this is a pipetted static tube. Okay, so it is commonly used variable head velocity measuring device. So where is the variable head velocity device? Better known as the airspeed indicator used in aircraft, invented by Henry Pipetted in 1732. Okay, so this picture shows where the pipetted tube is located. Okay, so how it works? Okay, it consists of two hollow tubes that sense pressure at different places within the pipe. Okay, 2 hollow tubes, the keywords. Next, this hollow tube can be mounted separately in a pipe or installing together in one casing as a single device. Okay, one tube measure the stagnation pressure here, or we call it impact pressure, and another one tube is to measure static pressure, okay, which is usually is installed at the wall of the pipe. Okay. The feed flow can be measured by measuring the differences between the pressure at the normal flow line, static pressure, and the stagnation point, which is we call it stagnation pressure. Alright. So next, okay, from Bernoulli equation between a point in the free stream and another point at the tip of the stagnation tube. So this is the equation, which is P static over rho plus V2 over 2 equal to P stagnation over rho. Okay. So next is advantages of pipetted tube is simple and low cost, no pressure loss in the flow system, easily inserted to a small hole, and useful in checking the mean velocity, but it is not suitable for measuring low velocity less than 5 meter per second, and it's sensitive to misalignment. Okay. 2% error, and not suitable for highly fluctuating velocities. Okay, so how the pipetted tube works, we will watch the video after this. Okay, so you can try this problem 13.5, okay, by yourself by using this formula. Alright, okay, so this is the answer. So next, let's watch a video how pipetted tube works.